Welcome to the Deep Dive. Today we're diving into the really surprising world of a tiny fish, often called the jewel of the Rio Negro. We're talking about the cardinal tetra Paracharodon axelrodi. It's small, rarely more than 5 centimeters. But there's a remarkably complex story here, way beyond just what you see in an aquarium. Our mission: uncover some fascinating nuggets about its biology, its rather contentious discovery, its role as a kind of economic cornerstone, and a really groundbreaking conservation model. Let's jump in.
It's amazing, isn't it? Such a small fish causing such a stir. You know, its appearance on the world stage, this was post-World War II, it was a huge sensation. And part of that was this dramatic scientific race back in 1956.
Race? Between who?
Well, you had 2 different teams, Leonard Peter Schultz from the Smithsonian, and then George Myers and Stanley Weitzman from Stanford. They both, almost at the exact same time, published descriptions, which naturally led to 2 different scientific names.
Oh, okay.
Yeah.
So Chirodon axelrodi and Hyphosauricon cardinalis. Was this just, academic bragging rights? Or was there more to it?
Oh, there was definitely more. There was a significant commercial angle driving this rivalry. See, Schultz's description, it ended up in Herbert R. Axelrod's magazine, Tropical Fish Hobbyist.
Right, the big hobbyist publisher.
Exactly. And the timing was, well, reportedly just 1 day before the Stanford team published their findings.
1 day. Wow, it's cutting it close.
It really was, and it sparked this pretty heated dispute over who had priority, who got there first officially. It went all the way to the International Commission on Zoological Nomenclature, the ICZN. They're the ones who sort these things out.
And they decided.
They ultimately ruled in favor of Schultz's name, axelrodi. So that commercial interest, Axelrod's push, it really shaped the whole scientific process here. It shows how, even pure science can get tangled up with market pressures.
Fascinating. So beyond that naming drama, what about the fish itself? Its biology must be pretty special too.
Oh, absolutely astounding. It's perfectly built for its home. We're talking about the Rio Negro and Orinoco basins, these tea-colored black waters. They're extremely soft water and incredibly acidic.
How acidic are we talking?
Often down to a pH between 4.0 and 5.0. Think weak vinegar, maybe? And yet this fish thrives. You can tell it apart from the neon tetra pretty easily, that iconic red stripe. On the cardinal, it runs the full length of the body. On the neon, it's only half length.
Okay, got it.
But here's maybe the most surprising thing about its life in the wild. It's basically an annual species.
Annual? You mean it only lives for a year?
Pretty much, yes. There are these massive die-offs during the dry season, so maybe a year and a half max, which is, a huge contrast to the 4 or 5 years they can live in an aquarium. It's this live fast, die young strategy, a really key adaptation.
And that adaptation, that annual cycle, is crucial for understanding its economic role, right? It's a huge deal for the local communities.
Absolutely massive. It's the economic lifeline for the middle Rio Negro region. You have thousands of local fishers, they call them piaberos, relying on this wild fishery. I mean, in some areas, like around the town of Barcelos, this one fish can make up something like 80% of the local economy.
80%. That's incredible.
It really is. And this leads us straight into something called Project Piaba. It's a conservation model, quite unique, and their slogan is pretty provocative. Buy a fish, save a tree.
Buy a fish, save a tree. How does that work?
Well, the core idea is this. Sustainably harvesting these wild cardinals provides a direct economic benefit to the local people. That income gives them a powerful reason to protect their rainforest environment. It stops them from turning to more destructive things like logging or cattle ranching.
That kind of goes against the grain, doesn't it?
Yeah.
We often hear that captive bred is always better, always more sustainable.
That's the conventional wisdom, yes. But here, it's different. The rise of cheap, mass-produced cardinals from aquaculture, especially in Asia, actually threatens this whole system.
Oh, so?
Because it undercuts the price of the wild-caught fish. If the piaberos can't make a living fishing, that economic incentive to protect the forest disappears. And that could actually lead to more deforestation, not less.
Wow. So the wild fishery collapsing is actually bad for the rainforest in this case.
Potentially, yes. And look, the species itself, the cardinal tetra, it's listed as least concern by the IUCN. It's not endangered. Plus, they are incredibly fertile. A single female can lay up to 500 eggs. So the fishery is basically harvesting a natural surplus, fish that would likely die off in the dry season anyway. It supports the argument that it can be sustainable.
It's not just an economic driver, though, is it? This little fish is also inspiring science.
It really is, that stunning blue stripe. It's not pigment, it's structural color.
Structural color, like a butterfly wing.
Exactly like that. It's created by these tiny, precisely arranged guanine nanocrystals in the skin. They act like microscopic Venetian blinds. Depending on the angle, they reflect light differently, creating that shimmer. And this biological marvel, it's led to biomimicry.
So science is copying the fish.
Pretty much. They've developed new color-changing materials based on how the fish does it. Think potential for dynamic camouflage, maybe even new kinds of display screens. It's amazing this tiny fish is like a living patent.
So wrapping this up then, the cardinal tetra. It's clearly way more than just a pretty fish in a tank.
Absolutely. It's a biological marvel, yes, but also a key economic engine and really a symbol of a very complex conservation puzzle.
It really makes you think differently about sustainability.
It does. It pushes you to look beyond simple answers like captive bred good, wild caught bad. You have to understand the specific context, the local realities, the choice you might make, even for something as small as an aquarium fish, can ripple outwards, you know? It can affect thousands of people and huge ecosystems very far away.
A powerful reminder of how connected everything is. What does this complexity tell us about how we should approach conservation in general, especially in our globalized world? Something to think about.